Welcome back. Hopefully you had a chance to get that coffee or tea, because now we're going to sit down for an incredible keynote. Dr. Amy Loutfi is the Pro-Vice-Chancellor for AI at Örebro University. She's also head of the AASS Machine Perception and Interaction Lab, co-director of the Wallenberg AI Autonomous Systems and Software Program. I also just followed her on Twitter, and I am excited to learn more. So please join me in welcoming Dr. Amy Loutfi.
Thank you. Thank you so much. So I hope you all hear me. It's really a pleasure, thanks, to be here and to be able to spend the next hour or so with you talking a little bit about research, but also talking about how we work with AI in Sweden. And also I want to give a little bit of a European perspective. Let me start by sharing my screen, and if I can just get a confirmation that you can see my slides. Good. All right. So I titled my talk Semantics for Robots, and I'm going to spend a bit of my talk getting a little bit technical, because I think that's a lot of fun. But I also want to give you a little bit of a background into who I am, why I'm here, and how sort of my links with Canada have emerged. Josh, he gave me a good introduction and said that I was born and raised in New Brunswick, which is true. And I kind of found my way to Sweden through my own path, but there are reasons why I stay in Sweden. And I'd like to motivate those reasons for everybody, just to show you what's happening on the AI and robotics scene here. So just to let you know where I am at the moment. So it's afternoon, soon to be late afternoon on my side of the world. Örebro is located in the midpoint between Stockholm and Gothenburg in Sweden. It's considered still relatively south of Sweden. Sweden is a very long country. And the university where I'm located, it has about 15,000 students. It's a relatively young university. It's been a university for about 20 years, which is very little time in Sweden. It has before then been what's called a college, which is another sort of way of describing higher academic institutions. And Örebro University is a very broad university, meaning that it has both the technical disciplines, but it also has medical professions and the humanities and the arts. And you can find in Sweden that sometimes the universities are also divided with this in this respect, that there are the technical universities contra the more broad universities, which we are. And I'm affiliated with a research group called the Center for Applied Autonomous Sensor Systems, a pretty long name, where we're about 60 or 70 researchers, all working within a very sort of, let's say, confined common vision of working on the intersection of AI and robotics. This means that we develop AI methods that are particularly suitable for robotic platforms. So we have some people who are expertise in AI, some people who are experts in robotics, and then we have also people who sort of master the bridge between the two. And if you're looking at who's on the screen, you actually see a picture here of Josh, who I met when he came as a visiting professor here at Örebro University, working with a mining company. And this is the way that we work at the center. We're extremely international. There are actually very few native Swedes here, but people come from all over the world to meet in Örebro and to do research in AI and robotics. And as a research center, and as an excellent research environment, and I say that because it's actually sort of a term that we use in Sweden to denote strong research environments. We are responsible for research, but we're also responsible for delivering education and responsible for collaboration. So in Sweden, the universities put a lot of effort on what's called the third directive, which is engaging in a strong collaboration with society. And this is a very important dimension on how we organize higher education in Sweden. Now, I mentioned that we were a highly international group, but we're also very much a European research center. And that means that we work on a lot of European projects. And for those of you who may be familiar with European projects, they all have these very strange acronyms. Very difficult sometimes to figure out what the project does based on the acronym, but I put 4 of these acronyms in, I highlighted them on the screen in case you're interested in understanding what are the main projects / platforms that are currently being run in AI today in Europe. And you have them like AI for EU, Taylor, Humane AI. And these platforms are really much focused on building the stage for European AI. So I encourage you to Google them or have a look if you're curious about the European perspective in terms of what's being done from researchers around Europe in AI. Now, I mentioned that we are also responsible for education, and I just wanted to lift here that we have a couple of different education programs where we're now bringing in AI into the education program. So in our engineering education, it is now profiled towards AI. We have a lot of AI content. We also have an international master's in robotics and intelligent systems. This could be of interest if you're interested in coming to Sweden and doing a master's education. But we also do something a little bit special, which is that we run professional education for free to industry in the area of AI and autonomous systems. This is something that the Swedish government has lifted in the past 2 or 3 years, where there have been special funds allocated to universities to do what's called lifelong learning. And what we do is we deliver courses in sort of a hybrid format. Half are digital sort of lectures, but also half of the course involves coming on campus and working in our labs, where we're meeting industry, and they're getting a chance to take part in the knowledge we have and getting a chance to do competence development. And I really want to stress here is this is completely free of charge for industry and is funded by sort of national strategic funds. And a lot of these companies maybe you won't recognize, but some of them you might, like for example, Spotify, where we have a lot of companies coming to the university trying to get the latest in machine learning or specific techniques, and meeting with our researchers. And what's really nice in this kinds of initiatives is that when we sit with representatives from industry, they come to us maybe with a data set that they're interested in using as their course assignment. And with that data set, we can all of a sudden create sort of new research projects together. So education is finding a way to feed our research. And this is a little bit how we're starting to talk about what we call our AI ecosystem within the university. And one of my roles, since I have this title of Pro-Vice-Chancellor, it means that I'm responsible for a certain area, and I'm Pro-Vice-Chancellor for AI at the university, which means that I work broadly with developing the university in terms of research, education, and collaboration, all when it relates to artificial intelligence. Another thing that we've done, because I've talked about education, I also saw a few years ago that we needed to maybe formalize this way of working with industry. So we've created what's called an impact lab, and it's not quite like the Ingenuity Lab that you have at Queen's. It's a little bit different in that what we do at the impact lab is we help industry, but also the public sector to implement AI. And one might say, well, why is this landing on a university? And one of the reasons is because a lot of the sort of specialized competences when it comes to AI and robotics is at the university and with the researchers. And we see it as kind of our societal responsibility to help local companies, but also national companies actually come to the point where they can implement AI and use AI as a tool. And again, this engages companies in projects, research projects together with us. So it feeds back to the research environments, but it also feeds the knowledge out into society. And so our Impact Lab is one way that we work a lot on collaboration. We also work with physical labs. So if the Impact Lab is an organization for collaboration, we have a couple of physical labs where we can actually work with our robotic systems and get our hands dirty. One of them is in sort of the area of smart homes, as we see, smart cities, and also AI and robotics really coming out for citizens and for the good of society. We have these apartment buildings and also living facilities where we test and field technology. But we also have our robotic labs, which we've built, where we constantly take in visitors and people from the public to see demos of the research, but also come with their input. Again, fostering interaction so that we can find new ways of collaborating together. And this picture here is kind of a reflection of what we do at the university when it comes to research. So here at the bottom of the slide, you see AASS, which is the excellent research environment that is responsible for doing basic research in AI and robotics. When it comes to collaboration, which we do at the Impact Lab, and when it comes to education, and I mentioned one example where we have a program called Smarter working towards professionals. And if you would zoom out from what's happening at my university, Örebro University, and you want to look at what's happening in Sweden, we have kind of a mirroring of the efforts we do at a local level, but at a national level. So excellent research in Sweden in the fields of AI and autonomous systems is being mainly driven by a constellation called the Wallenberg Autonomous Systems Program. It's called VASP, so the W makes a V sound in Swedish. And I'm going to spend a bit of time at the end of my lecture telling you more about that, because I think there are a couple of opportunities there that some of the people in the audience I hope will find relevant. When it comes to implementing AI and really helping the public sector on their transformation, we have our initiative at the university, but we work very much with a national platform that does the same, which is called AI Sweden. And actually AI Sweden just opened an office in Montreal to try and connect better as well to the Canadian AI ecosystem. And then I mentioned our program for professionals and working with sort of working professionals on their competence development. And if you look at AI competence for Sweden, we're all working in a network and together with the same ambition to try and raise the competence level in all industries, particularly the small and medium enterprises when it comes to AI. So this is kind of a snapshot of how the AI ecosystem in Sweden looks today, at least when you look at how the AI ecosystem is connected to academia. All right, so that was a beginning of kind of the Swedish view. Now I'd like to just shift perspective somewhat and go back to the research. So I'd like to talk a little bit more about what we're doing at the Center for Applied Autonomous Sensor Systems. And I would like to talk about my research in particular. So what am I doing with my research group? And I mentioned that AASS has a number of researchers. We're almost 70 or so researchers working on the intersection of AI and robotics. And that basically means that we focus on the perceptual and cognitive abilities of autonomous systems. And we're really keen on developing these systems that work in the service of humans. So they're working for humans, but they're also working with humans. And at the center, since we're such a large group, we're sort of subdivided in different subgroups, or we call them labs, where we focus on different scientific questions. And my lab is called the MPI lab, where there's a lot of focus on machine perception and interaction. And this basically means that we're taking a look at how do we interpret data that is coming from sensors, How do we augment that information so that it can be used not only by agents like a robot system, but also be used when humans and robots interact with each other. And I want to tell you a little bit more about one of the directions that is starting to emerge in our lab, in the Machine Perception and Interaction group, and give you maybe a few examples of the projects that we're looking at, some together with industry, but some are also very much basic research in AI and robotics. And I'm going to try and stay at a fairly popular level, but anyone is welcome to ask, any technical questions about how we're conducting the research. So we heard from the introductions that, there's been enormous sort of strides made in the field of artificial intelligence. And when we look particularly at deep learning and perception, we see that there's been rapid progress in certain sub areas, like, for example, image recognition. And these kinds of algorithms, as we know, has enabled us to do a lot of things. We're very good at things like object detection, object recognition. So not only being able to find where the object is in an image, but being able to say what it is, if it's a cat, if it's a dog. We're also good at doing things like segmentation. But when you're dealing with robotic systems that are expected to interact in the world, objects are indeed much more complex than just simple pixels in an image. And getting robots to understand that is one of the kind of motivations that we have within the Machine Perception and Interaction group. And the following pictures maybe give you kind of this example of how we sort of have what I would call a non-trivial view on objects. So, for example, objects have multiple and changing properties. Cup of coffee, like the one I have here, it's not just what I see, but it's also what I smell and what I taste, how the texture of the coffee feels when I take a sip of the coffee, how the temperature of the coffee changes, and how the taste of the coffee changes with respect to the temperature. Objects also have affordances. I know, for example, that this very same cup can be used as a container, but if I would drop the cup and it would shatter, it is no longer functional as a cup. Whereas if you see a picture of the carrots on the screen, if you would cut a carrot, it still serves the purpose of being a carrot and is still edible. Objects also have these characteristics about them, like, for example, they don't magically appear and disappear. And in fact, this is something that we need to learn, even as small children, how objects are in the world around us. The idea of permanence is not something that we are born to understand, but we learn through time and through interaction. So you see, for example, someone playing peekaboo with a baby, and the reason why it's so exciting is because when you cover your face, you actually do disappear for a baby until you learn that objects have permanence, or objects can be, for example, decomposed. And objects also can interact and impact their surroundings, like the picture of Peter Pan that you see here, that he's interacting with his shadow, and objects can cast a shadow, but the shadow in itself is not considered an object per se. So there's a non-trivial view about objects that allow us to interact with objects. And the question is whether or not we can endow machines with that deeper understanding of the objects around them. And why is this important? Well, this becomes particularly important as we move into very dynamic and unconstrained environments with our robots, right? We also want to be able to interact with our robots in a way that is natural to us. We want to be able to say to our robot, pick up all the toys. And it should be able to understand what's a toy and what's not a toy being maybe a class of different objects, or find my glasses and know which glasses are the ones that I typically use. These kinds of interactions would make it much easier to have objects, to have robots around us But to do those kinds of tasks, we need robots to have a deeper understanding of what objects are in the world and what you can do with them. Sometimes as well, as I mentioned in the case of picking up toys, there has to sometimes be a process of reasoning about objects and being able to infer beyond what can be measured. So now we're starting to get into the AI topics. And interaction, of course, is highly facilitated when we have this shared understanding of the world, as in the case of Find My Glasses, that we both, me and the robot, understand what I mean when I say my glasses. Now, why are we looking at this? And in particular, why am I looking at this particular area? Well, my interest in research started during my PhD when I was looking not at the area of computer vision, but I was actually doing my PhD in a very sort of odd area, which was the area of machine olfaction. So how do we get robots in particular to be able to perceive odors? And how can you integrate an electronic nose onto a robot so that you can navigate, for example, to a particular gas source? And as I was doing this research, I realized that when we're working with this kind of sensing modality, there is actually a lot of reasoning that we do in order to, for example, localize an odor source. One way, of course, is to equip the robot with gas sensors, and then it simply looks at the strength of the signals and navigates to where the odor gets stronger and stronger. But if you did that, and we did some experiments, and that's actually what I'm showing at the bottom of the slide, I'm showing sort of a gas distribution map where you see sort of a red sort of circular dot, which is showing you where the highest concentration point is. And in the middle here, you're seeing where the gas source is located. What we find is that the point of highest concentration is seldom actually located right above the gas source, simply because there are, air currents and factors which is sort of moving around the gas inside a room. And we understood, well, we need much more than just olfaction. We need other senses. We need to reason about the environment. We need to reason about the objects. So I started in the field of olfaction, but as I moved through my research, I actually saw the importance of bringing in influence from other sensing modalities. And I also saw the importance of bringing in also interaction components. And people often ask, why are you interested in robotics in particular? And my answer usually is because you need so much to be able to do research in robotics. You need to look at how humans behave. You need to look at the physics of the world. You really bring in everything when you try and design the next generation of machines. And so my journey, which started in olfaction, actually led me looking into much broader topics in the field of AI and robotics. So that was just kind of a parenthesis. So I hope I managed to convince you by now that, if we want robots working in the world, just simply doing computer vision is not enough. We need to actually extend our ability to recognize and identify what we see in an image, to actually create a shared understanding of what the objects are. So in other words, have some semantics connected to that. And now I'm going to just go through 3 examples of where we're using this philosophy of semantics for robotics in our various projects at the university and within my research group. So one example is to play some games with our robots. And one type of game that we look at is something called the shell game. And some of you may recognize the shell game. There's a little vignette there on the screen where you simply hide an object under a cup and you move the cups around. And we asked ourselves whether or not we could get a robot to solve this task. We know sometimes even as humans, we can get fooled by this task. And as we started to decompose the task, we realized it's quite complex, because you have identical cups, right? So one of the things you have to do is keep track of each individual object. Then you have this, in this case, a coin being hidden under one of the cups, which means you have to understand or you have to learn about permanence that we talked about before. So just because you don't see the coin doesn't mean that it's disappeared. And then you also have to figure something else out, which is that if the cup moves, the coin will move with it. And all of these things are, as I said, maybe not so intuitive at first sight. So our question was whether or not we could get a robot to solve the same task. If we could, in essence, play the shell game and get the robot to solve the same task. And again, I'm not going to get too technical, but what we saw in these experiments was that we needed both to learn about the world, and we also needed to reason about the world. So this is basically bringing two fields together, the field of neural networks and the field of symbolic reasoning. And this is some of the experiments that we've been doing where we've actually started to learn to reason. And to take you through that, and you can just have a look on the screen and just see these examples. If we look at the one, for example, on the right, the green dots are showing the belief of where the robot believes the object is hidden. And as objects move around, the robot has received no further evidence to suggest that the object is moved out of block one. And in fact, block one, once it is, the cover is revealed, you see that it can reacquire or reallocate the original block. So here what we're doing is we're starting to learn the notion of permanence, basically learning a rule that if one object occludes another and you don't see it again, you assume that the object which has occluded it is hiding it, that it's still there. And we see how the system is slowly able to learn this, this rule over time. Another example that I wanted to show you is also how we can bring other methods within AI to do what we call language grounding. So language grounding is the task of really understanding that when I say blue box, it refers to this specific object, and being able to ground the notion of blue and ground the notion of box into something that you perceive, into your perception. And when you can do that, you can then start to manipulate these symbols. So I can say a blue cup, and because you understand what blue is, you can sort of use it to describe other objects. Or I can say a green box, and because you understand the notion of box, it doesn't matter what color it is, you know what is a box. And this is a common area in the field of cognitive robots, where we want to understand how do we as humans ground language, and can we get robots to do the same thing? And some of you may be familiar with this area of language learning, where you're using techniques, for example, GAN. So you're generating data, mass amounts of data, to be able to ground language to what you're seeing in this image, and then you can query an AI. So for example, in the image I'm showing you, which is basically coming from what the system called Clever, you can start to query the image and say, well, what is the object beside the red sphere? And the AI should be able to answer those queries. This is a very sort of interesting field that is being examined by a number of researchers around the world. And what we asked ourselves is, if we want to learn semantics, can we take this step one even further by not simply just grounding, let's say, the nouns and the adjectives, but also could we ground actions? Because as we know, in the world of robots, actions are very important. And so using this idea of GANs, and basically using how we can simulate data, we trained objects on the effect of actions. So we looked at many scenarios in simulation where we would move objects. For example, instead of just saying, what's the object to the left of another object, we said, can you move the object, for example, the green box? Can you move it on top of the red ball, as you're seeing here on the slide? And why are we doing that? Well, we're doing that because we believe that if we can train a robot in simulation on the effect of moving objects, then we can move that training scenario to the real world and get the robot to perform the same actions, but this time actually performing the actions, like I said, in a real setting. So it's kind of like you allow the robot to dream, and kind of through that training and dreaming, if you like, in simulation, it practices certain actions. And then in the real world, it can actually do those actions, even if it's never done it before. And that's kind of the motivation behind this research, where we're grounding language, but we're also grounding actions. And in fact, when we tested this, we see that the output, when we gave it sort of novel instructions. So at the bottom of this slide, we gave it an instruction like move a green cylinder on top of the red cylinder or red ball. We end up getting generated outputs. And this is basically showing you what's inside the brain of the robot at the time. So we're getting a generated output that shows you what the robot thinks the end effect will look like. And you can see it's not beautiful. It's not important that it's beautiful, but it isn't completely incorrect. So this basically means that we can start to get to the point where we can use natural language to instruct robots with sort of never seen before instructions. And we can sort of open up the robot and look inside and see that it's somewhat understood what the effect of this instruction would be. And this is quite important because, of course, once we deploy these robots out in the real world, we want to make sure that when we ask it to pick up all the toys, it's going to pick up all the toys and not, throw the toys out the window. So this is kind of one way that we can visualize the outputs by looking at, again, the semantics of what these machines understand. And the last example I'm going to tell you about is, again, how we look again at semantic perception, but this time we decided to scale up because a lot of the examples that I've showed you, they're kind of what we would call toy examples. And now we said to ourselves, well, can we do something large scale and can we do something maybe that has a big impact? So we contacted our defense, it's not really a defense agency, but rather it's one of the largest companies working on national security defense. They look at emergency situations as well. Saab, which I think some of you may be aware of, some of you may think it's the car company, but it's not that Saab, it's a different one. And we talked to them about whether or not we could look at large-scale semantic perception in urban environments, because we knew that they were collecting beautiful satellite data about urban environments, and try and see whether or not we could look at applications like climate change and climate impact, bringing robots into the mix together with all of the work that we've been doing on semantic perception. And what we ended up doing together with Saab is we ended up getting a lot of data from them. These are satellite images that also give us, let's say, a height information. And we basically take these images and we analyze every object in the image. So now we're talking about hundreds of thousands of objects that we're picking up. Things that are buildings, we pick up individual trees, we pick up individual entities in the image. We label everything, like, for example, car, building, road, but we also connect those labels to meaningful information, that particular building is a school. And of course, you can get this information just by looking on the web, but we wanted to get this information by doing image processing, because what we wanted to look at was not just the static information, but what happens when there is an emergency scenario, like a flood. So what happens when there is a sudden event flood, an earthquake, where all of a sudden the environment changes? Can we dispatch the satellites and again acquire information about all the objects in the environment? And because we've augmented the information at a semantic level, can we then allow for both humans and robots to use those images in order to plan tasks? So a human, for example, just after a flood could ask, where are the shelters? And using that semantic information that we have a building here, but this building is a school, and right now that building is not underwater, we could answer that, okay, the shelter is this particular building at the moment. So you see, we have a notion of affordance. We also use the same information, or the same type of queries can be asked not by a human, but can be asked by a robot. So in here, we have a drone that is asking, how can I fly from point A to point B and avoid water? And if some of you who are working on path planning, you know to do this in 3D is a huge effort. But if you understand the semantics of your environment, like bridges connect 2 points of water, then actually what you can do is you can prune the search space, and the robot can very quickly find a path using bridges as a way to narrow down where I search in order to make my path so that I avoid water. So there's a very sort of high level description of this work, and this work is ongoing, and we're very interested in pursuing it further, particularly as we see that we are in a reality where we need to cope with these sudden events, often caused by climate change at the moment, and being able to use the combination of human, robot, and AI in order to team together to help in certain scenarios. So here you see, for example, that now the drone has found a path, ironically in Stockholm, and water is everywhere in Stockholm if you've ever been there, but we can narrow down the search space. All right, so just reaching an end of the tech part of my talk, that if we have a deeper understanding of objects that are around us, and robots also have that deeper understanding, that we can enable a better interaction. And I hope that I also was able to show you that we can also have sort of better AI algorithms by, for example, making path planning methods a little bit more effective. And that's kind of what we're doing at the Machine Perception and Interaction Lab. And a lot of that work is being driven by many of the fantastic researchers in my group. And it's also being driven a lot by some of the basic research funding that we have from VASP. And with that, I just want to spend 5 minutes more before I round off and talk to you a little bit about VASP, because when I was speaking to the organizers of the event, we said, let's give a mix in my talk a little bit about the technology, talk a little bit about how the university works with AI. And now I want to tell you about a very exciting research program that is really changing the landscape in Sweden. And I hope that it's something that will interest some of you. So VASP was an initiative started about 2016 when the Wallenberg Foundation, which is the largest private research foundation in Sweden and one of the largest private research foundations in the world, decided that it was important to put dedicated research in the field of autonomous systems. And about 3 years ago, extended that to also include AI. And everything that is done within VASP is about basic research. It really is about excellent research in AI autonomous systems software, and also math is a very important aspect. So there's a lot of funding going towards mathematics research for AI. And although it's basic research, it really is basic research that is designed to push the forefront for, let's say, Sweden and Swedish industry. And when I say Swedish industry, a lot of these companies like Volvo, Scania, Epiroc, Atlas Copco, Ericsson, they are also multinational companies. Now, the funding scheme is about 5.5 billion Swedish crowns, which translates roughly into about 800 million Canadian dollars for the next 15 years. So it started in 2015 and it will stretch until 2030. It involves 5 universities plus research groups at Örebro, so that's AASS, and also a research group at another university. And there are about 58 companies who are also providing some co-funding, access to equipment, but also going in with some cash. And what we're doing in VASP is we're really focusing on building the next generation of human beings. That's to say, the next generation of PhD students and research excellence. The research school aims to have 600 PhD students. We're at about 350 PhD students so far, and to establish 80 new research groups. And there are a number of instruments, and these are basically open calls for Swedish researchers, and also in a bit there is some possibility for collaboration to apply for funding from this program. I mentioned that we have a grad school, so this is the 600 PhD students. We have what we call strategic recruitments. These are recruitments of assistant professorships, and chairs that we have quite regularly. And they come with quite generous recruitment packages, usually of a few PhD students and a few postdocs to get the professors going. We have also a program on internationalization, and I'd be very interested in talking a little bit more with maybe some of you offline to hear whether or not you'd be interested in connecting with VASP, and a lot of events and networking, not so unlike what you're doing here, in order to get the community going. And it's a very focused research program on a number of, let's say, thematic areas. And here, when you look at these areas, from my perspective, I see a lot of that intersection between AI and robotics that we talked about before. But I think one thing that's interesting to note is that we haven't forgotten the very important foundations. So, for example, the mathematical foundations and theories that are needed for pushing the research front forward. One of the things that we do in the graduate school is we organize trips. And in fact, in 2020, we planned to come to Canada. I actually was responsible for the international trip. And we had, chartered one whole plane where we had 100 PhD students going to fly to Toronto to come visit some of you. And unfortunately, the pandemic hit and it was just not possible to do. But we are still hoping to be able to travel soon. And every year, finding a few locations around the globe to go visit. And I think Canada is a definite location for us to come and see, particularly with the AI ecosystems that you have. So you may have a chance to interact with some of our PhD students in different ways. And internationalization is very important. In fact, when we work with recruitment, we're really interested in recruiting talent into Sweden. And we've done a number of recruitments so far. The chairs that we've recruited, they are really sort of top-level researchers in the world that have come and relocated to Sweden. And they come with quite generous recruitment packages, as I said. And we've also recruited a number of assistant professors. So those are people who are usually after one postdoc period or 2 postdoc periods, come into the assistant professorship program in Sweden and have an opportunity to build their own research group. I mentioned industry, and one of the things that this initiative is doing is it's working a lot with so-called research arenas. And these research arenas are basically large demo platforms. I mentioned our own robotics lab. Well, this is kind of like the robotics lab, but much, much larger, where we're doing demos, we're creating data, and we're looking at things that are a bit closer to real world problems where industry can be engaged with our researchers. And we have a few themes. We have one on robotics. We have one on public safety, which is a lot about sort of dealing with those scenarios that I talked about before with disaster management and these things. But we also have one about media and language. where it gives a chance for us to look at, again, real world scenarios, even though we're still focusing highly on basic and fundamental research. And we also within the program create initiatives with specific universities. We've been focusing on NTU in Singapore, also MIT and Berkeley have been very high on the list of our sort of partnership universities. And we're really looking to expand those partnerships to universities where we share kind of a common vision and initiative to strengthening basic research. And like I said, we work with events. It's a network like many of these sort of national scale networks are. Perhaps something that's interesting to mention is that as we're all working on AI, we also shouldn't forget the need for infrastructure. And one of the things that we've looked at within VASP is the ability to create a national infrastructure. And we now have basically our national infrastructure, the specs you can see on the slide here, that is open to all the VASP universities, but also really open to research in general in Sweden, where we want to be able to give them the access to the infrastructure that they need for running their algorithms. And here we really are keen that our PhD students get access to this infrastructure. The physical machines sit in Linköping, which is not very far from Örebro, but of course it's accessible virtually from all over Sweden. And I'll just skip that slide and just go to this slide, which is basically saying that if this sounds interesting to you, whether it's the research that I mentioned or this larger initiative VASP, there's always open positions. There's open positions for postdocs. There's a lot of open positions for PhD students. There's open positions for researchers. So I hope that maybe there's something in here that may interest you, even as a visitor or a guest. And that we can find ways together to bridge between what's happening in Canada and what's happening in Sweden, and really push the field forward. I will stop sharing my screen, and I'm very much open to any questions. And thank you very much for listening to me.
Thank you so much. That was fantastic. And we do have questions coming in. We have about 10 minutes left for questions. I'm going to ask a quick question first. As you were speaking, I was curious how the COVID-19 pandemic has accelerated your research and even what is happening right now when it comes to adoption of AI within industry.
So I think what the pandemic has done is it's given everyone sort of a crash course, of course, into digitalization, right? I mean, we've had our largest teleconferencing experiment worldwide, but I would still be a little bit hesitant to say that it's given everyone an awareness of AI. I think actually the pandemic in itself hasn't increased the awareness, rather perhaps a few, let's say, scandals happening with data and social media that maybe has contributed more to our understanding of algorithms than the pandemic per se. But from a research perspective, there have been a number of benefits of the pandemic and working digitally in this way. One of them is that it's been much easier to connect to each other. And I see it even on running PhD defenses, right? That now we can really bring in international experts to be on a PhD defense much easier. And we accept that we can examine PhD students via Zoom, where before it was, not really encouraged. The other is that we can easily have an exchange of ideas. I can participate at your venue very easily now, whereas before it would have taken quite a bit of effort. So I think, just doing research in general, it's become easier for collaboration. I hope that post-pandemic, the next logical step after this sort of digitalization boom will be an AI awareness, more so in the general public, but we'll see. We'll see how things develop.
All right, we have a question here from Ramsey who asks, do you collaborate with psychology and/or neuroscience researchers, and would this be of benefit?
So we collaborate a lot with psychologists, particularly when it comes to evaluation of human-robot interaction. Their understanding of how to do user studies is really fundamental. We collaborate a lot with medical professionals as well when it comes to sort of going into the applications of AI. But we haven't had as much collaboration with neuroscientists as I would like. I actually think that the intersection between neuroscience and AI would be really fascinating. But sometimes there's still a really big gap to be bridged between our mathematical models of neural networks and our biological ones. But I think this is an area that would be really exciting to explore further.
All right,
it's a good question.
From Gerald, who asks, seems like the focus currently is on categorization/distinction. Can you imagine a future where cognitive technologies can infer a meaning or meanings by interpreting the relationships among parts, aesthetically consummate the scene/image?
Yes, that is exactly what we're working towards. So I think that is our call to action, that we really want to have that deeper understanding of what's happening inside. In our cases, we use images, but I would even like to challenge it further and say, really look at all senses, not even just to go to the vision senses, but it would be a dream of mine as well to go into the other senses where we're perhaps not as strong, like olfaction.
I had a question for you about that. I was thinking about COVID-19 and dog sniffing dogs in healthcare, and just all of the applications of that. But I do want to get to an audience question. This one is from Xiaodin Zhu, who asks, computers/robots seem to have difficulty to compete with a 3-month human I think I just lost it, enfant in many aspects, e.g. Obtaining intuitive physics and psychology. Do you think if one of the first steps for artificial general intelligence should be enabling computers to learn intuitive physics and psychology?
Very good question. So there's a lot of work. Tenenbaum, for example, has looked a lot at how you can learn the physics of the world. Really interesting, also bringing in the psychological dimension. And I think we have to always ask ourselves why. Also, whenever I get the question about AGI, artificial general intelligence, I usually say, well, why do we need it? Why do we need to develop it? And I would say, my opinion is that bring in psychology as long as it will lead to a result that is complementary to us. So I don't think we need sort of more human-like entities running around in the world if they don't have any added value. I think it's important that the machines that we develop complement us. And we talked before, or somebody mentioned, can you imagine having a robot companion that's smarter than you? Well, I would argue even that my computer at sometimes is much smarter than I am, at least at computing things. So I think we're already in that reality. And I think that complementarity, when humans are good at what humans are good at and machines are good at what they are good at, and then they work together, that's when the magic happens.
Absolutely. Josh has a question here. The consequences to getting semantics wrong. How do we effectively incorporate safety into semantic reasoning for robotics?
Excellent question, which I don't have a direct answer to. But I think one way to at least, or one way that we're coping with it is in that example that I showed you where we were visualizing or doing what we call sort of neural rendering. So being able to understand what the system is learning before it actually performs the action. This is a way of doing sort of checks and balances and making more explicit how the neural network is at least seeing what would be the result of the action before I actually get the robot to do the action. So we need to have verifiability in AI and explainability and transparency. And all of those things are each of them, a hot topic that is being looked at today. But you're right, the consequences of getting semantics wrong would be highly detrimental to what we're trying to achieve if we have no way of verifying it before.
I think we have time to squeeze in one last question, another one from Ramsey. AI learning involves heavy computational needs. How are these needs managed in Sweden, and does each institution manage its own GPU cluster, or is there a national resource that researchers have access to, and is that funded?
Yeah, and the short answer is yes, that's what Brazilius, it was, I think one of my last slides or second last slide is all about. It is a national infrastructure of GPUs that is available to the research community. And it is funded by the Wallenberg Foundation. So that is our way to kind of make sure that the researchers have the tools that they need to move forward.
I said that was the last question, but I saw one just come in. So I'm gonna squeeze one more in.
All right, no problem.
This is from Ashley. Ashley asked, do you think it could be possible to give AI robots their own opinions to perform a task, like getting it to play devil's advocate for a solution? That's one example that she mentions. A solution to potentially find all the flaws.
Yes, I do. I think, for example, in medical robotics, or at least medical AI systems, I think having a devil's advocate, or I think having, a system that could challenge you would be an excellent companion. And it goes back to what we were talking about before about getting systems that can really complement us. And I think what you're saying, Ashley, is very interesting. It's not only to complement us, but getting systems to challenge us would be even better. So it's a good question, and I think I'll take it as feedback and a comment. So thanks.
Well, I just wanted to thank you so much. This is the perfect lead into our debate that we are just about to have. Thank you so much for your time, and hopefully next time we will be able to do this in person. Thank you.
Thank you. Have a good day for the rest of the day for everyone.